If you're looking to enhance your texturing skills using Substance Designer in UE5, this video is for you. I'll walk you through the process of creating a full texture set like the one I used to design this entire environment. With over 10 years of experience creating science fiction games like Destiny and Mass Effect, I'm sharing the techniques that I've been refining throughout the years. And now, you can apply them on your own projects. We will explore references and gather inspiration. We will model our sci-fi panels from scratch. We'll create a texture set in Substance Designer. We'll review the game-ready 3D assets that are made from this trim texture. I'll give a detailed overview on how to set up a material with its variants in UE5. And then finally, I'll walk you through the scene that showcases all of our work. I hope you enjoy, and thank you for watching. For the inspiration of this trim texture, I was looking at some of my art books, one of which is called Century 2 by the late artist Syd Mead. While looking at the artifact designs, I was really inspired by the material variety, the detailed distribution, the way the accent colors are placed, and the overall shape language is really modern, sleek, lots of angles. I'm hoping to capture these kinds of details on our trim texture. Let's start off by creating a plane where the length is twice the width. And let's give it 4 length segments. I'm going to add a couple of slices. The idea is to have these cuts represent the sizes of the actual panels that we're going to make. Now let's assign a couple of random colors to differentiate between each panel. Feel free to pause the video to be able to see the final panel arrangement. Now that we finished our reference plane, let's create these 2 square panels. Using a reference plane, let's create a rectangle over the 2 square panels, and then apply one of the materials. We're going to be introducing cuts vertically and horizontally. These are going to help us determine where the details are going to be. Let's add some cuts in the corners that are diagonal. What we're going to do now is select the polygons that are in the corners and delete them. And then cap the hole that it creates. Grabbing the center edges, let's create a chamfer to add some thickness. I want to select the polygons that are on the side, extrude them in while stopping at each edge. Let's add more vertical cuts. These are the ones that are going to help us define the shape that we're going to create. Extruding this polygon down, we're defining our shape. Now let's use our vertices and move them to the left. It sort of looks like a little flag. Now let's create a cylinder precisely where these edges are, the ones that are vertical. This cylinder needs to cut all the way through, so make sure it goes through the bottom and the top. And now using snapping, we can put it in position. Now I'm trying to determine the radius and the scale. I'm happy with this size. We're gonna transform it into a pill shape. We can do that by detaching the halves and then bridging the gaps. Snapping the pivot to the center, we can yet again center it on our model. Now we're ready for the boolean. But first, let's detach the part that the boolean is going to affect. 3D Max has a tendency of creating some unexpected issues with booleans. so I tend to separate the damage in case something happens. As you saw, that vertical edge suddenly disappeared. It's okay, we're gonna put it back later. With the Boolean operation completed, we can reattach the model. Let's separate both of the halves so we can have some space to model the panels separately. I realized that the welds were not done on that part that we Booleaned, so let's weld everything together first, and then we can cap the holes that we just created. Now we have both of our square panels separated from each other. This way, it's easier for us to add bevels and chamfers without having them overlap each other. Let's select the corners now. These are the corners that we want some tighter chamfers in. I'm thinking about 0.5 as the value. Never mind, the ones that are in the center are gonna be the tighter ones. Let's make these 0.25. And these as well, 0.25. Now we're gonna be moving towards our center detail. With a similar approach, let's select some that we want some chamfers that are a little broader first. These four corners look like they could use a bit more curvature. And then these two can be tighter. The reason is because I want to keep this angle that we just added, so it looks close to a 45 degree. This looks good. Now we just have a few edges left. This one can have a broader chamfer. This way it creates a very elegant curve. And these two can be tighter. And we're done. For a moment I was thinking these chamfers were gonna keep going on and on. Chamfers complete. Now let's select these edges and connect them with one segment. Because they're crooked, we're gonna use that edge constraint and scale it and move it into place. We scale it to straighten it, and then we move it using the grid. The ones on the left need to be scaled to the left, and that makes them straight. And now we're gonna create some distance between the points. This is gonna provide additional vertices in the center of the model, and then we can use these to target weld other vertices. This way, these are not close to the edge. When they're close to the edge, they cause issues with chamfers and bevels and other modeling operations. They need to stay away from the construction zone. It is dangerous. And now we can move the right panel to the left and snap them together where they belong. Let's create a new rectangle that is the same size as the original panel but not as tall. This one's gonna be filling up the negative spaces that we cut away from the original panel. Let's create some chamfers on the corners to smoothen things out. we can bevel the top edge. The top face. Let's use a value of 0.5 and then negative 0.25 on the inset. We need to remember these values because the bevels are going to be consistent in other parts of our trim. In order to avoid those polygonal sharp lines, we're going to add a chamfer here. And our normal map is going to show up properly and catch the light. Let's do the same for this one as well, but not as much. Now we need to move forward with doing the same thing with our white panels. I'm selecting the topmost faces and doing a bevel using the same value. But for this one, we have to check the entire model because there's a high chance that some of these are overlapping. We might need to adjust the values or fix it. In this case, I'm going to fix it. So let's commit to these. Now we're gonna do a delicate operation. Let's insert two cuts that are vertical and go all the way through. We're gonna be using the scale tool to make sure that these are straight, and then we position them on the grid. We do the same thing on both sides. Now that they're positioned, we can move the vertices that are below the problem area towards the center. We do the same for the ones on the top. Now we have set the stage for things to be fixed. The way we're going to do this is by selecting the faces that are problematic and deleting them. And then we're going to take the healthy faces, duplicate them by Control-Shift, dragging them down into the previously problematic area. And then we're going to use the vertices to snap them into place. And then we're going to weld everything together. Make sure that we don't have any gaps. Let's do the same thing for the top, taking the healthy areas and removing the sick areas. And everything needs to be welded properly, but not too much. As you saw, if we weld too much, the vertices that we modeled before, they collapse together, and we need to avoid that. Here we have another area that is problematic, so we need to weld it as well. That Boolean. It created a face that is turning black. This face has become too complex. To fix it, we need to cut it in half. So let's select the faces and use the slice tool. The slice tool needs to be rotated so it slices in the correct direction. And then we can snap it into place so it's exactly at the center of our circular detail. And then we hit slice. And as magic, the face is fixed. Now we need to select the edges at the top so we can do our chamfer. I converted the face selection to edges, and then I remove the edges that I do not want. This is the selection that we're needing to move forward with. So let's apply a chamfer. Looking at the top view, we can determine the thickness. We can reference the chamfers that we did before and keep things consistent. Done. This area also needs to be fixed. I didn't see it before. Let's weld it together. We're almost done with this part. We need to create something new. It's gonna use a different way of modeling. its subdivision. In 3D Max is called Turbo Smooth. So let's create a cylinder and place it where we have this hole. Using the top view, we can determine the radius of the cylinder. It's supposed to look like it's meant to be in this cutout. Perhaps it can go up and down like a switch, moving on and off. For simplicity, just call it a button. So this button needs to have more loops on the edges in order to keep its definition when we apply the Turbo Smooth. Now let's select the outmost edge, move it down to create a bevel, and then add more loops. Selecting the faces that are in the inside, we can create an inset. Another one, and another one. We're using these insets to shape the center area of this button. That way it's circular, it's round, it catches the light really nicely. It reminds you of an Xbox. And these edges need to be sharp, so let's extrude them down. This way when we apply our Turbo Smooth, you see it retains the definition. It looks like the button can be pressed. Let's apply some colors now. I'm thinking this can be a special color, one of our key colors. So I'm gonna apply a yellow. In Substance Designer, we will be able to easily isolate and apply something special to this button. Now let's go ahead and create the large detail panel on the top. The modeling techniques that we're going to be using for the large detail panel are going to be very similar to the ones that we used before. So let's start off with a rectangle that measures exactly the same as the reference plane below it. I'm also starting off with the height that I used for the two square panels. Let's introduce the edges that we need to determine where the details are going to be. Here I cut the model in half and detached one of the halves, and then I capped the borders in order to make the model watertight. Now we're working with the bottom half and adding more segments. It's divided into thirds, both horizontally and vertically. And now we're going to move the horizontal lines into place. And then introduce another cut in the center and move it up using the grid in order to create space for the new details. I realized that I need to hide this polygon, so I'm gonna detach it and remove it for now. This way we can model the bottom half without interruption. With these polygons selected, we can now move forward to the next operation. We're gonna detach them so we can work with the other part of the model. We're essentially creating different parts as this model has different height elevations that require us to separate these parts. Now we're selecting the top edge so we can extrude it. We can add another cut in this section and select these polygons so we can extrude them even higher. This is one of the panel details that cuts the model in a very elegant angle. As you can see, we're creating different components that have different height variation. I'm going to duplicate this specific polygon in order to retain the height and the width, and that is going to help us create a new part at the top of the model. Let's use the grid in order to assist and the location of these vertices. Let's add a couple of more segments to be able to add definition and extrude one of the edges down so it meets the bottom part of the model. And then we move the vertice to the left in order to create a similar angle than the one we have below it. I'm going for a 45 degree. And now, because we want to shape this part of the plane, we need to introduce more segments. Now we can move our newly created polygons down using one of the edges of the model below for snapping. As you can see, we have a very elegant design. It starts off straight, goes down in an angle, and then becomes straight at the bottom. And these edges are going to be creating normal map definition when we bake everything down. Now we need to shape that flat area below it. Let's introduce a couple of cuts that cut through the whole part horizontally. Right now, there's 2 new segments. Before extruding it down, I'm going to add a few more segments on the side of the model. That way we prevent ourselves from having polygons that are too complex. Now we can extrude the bottom portion down and create an area where we can place more details later on. Let's create a new rectangle in the right upper part of the model where our new detail is going to be. It's going to be a circular detail similar to the key accent detail that we have on the other model, that yellow part. We need to grab the top edges and make sure that the elevation is slightly higher than the area below it. I'm using the snapping in order to determine the height, and it's matching the height of other details on the bottom part of the model. Now I'm going to be applying some materials in order to help visualize one part from the other. I'm thinking that the bottom area that is dark gray can be all metal. And this strip here perhaps can be a key color, so I'm applying a teal for now. And this middle area, I'm thinking it could be our darker painted metal. I'm seeing that there's a gap in that area of the model, so I want to select that section and extrude it down. I selected the border and used the snapping to move it down. It doesn't matter if there's Z-fighting on the sides of the model. At the end, we will be projecting everything down into a plane. So what matters is what we see from the top view. I'm detaching this area at the bottom so we can continue modeling that in isolation. Now I'm deleting some polygons that I do not need. And I'm capping the areas of this model that we do need, extruding them down while snapping to the nearest edge. I'm doing my best to maintain the integrity of each part. That way when we start chamfering and beveling the edges, everything will work as it should. I'm starting off with this one and giving it a broader chamfer. This way we have a more elegant curve that goes all the way up. Now I'm selecting corners that I need to chamfer. Once they are selected, I'm going to go to the top view and perform the action, making sure that everything is looking good. I'm detaching the top part from the bottom. After that, I'm selecting that bottommost edge from the bottom part and giving it a broad curve. Then we're going forward with a similar process for this part as well, choosing which chamfers and which radiuses we want where. As you can see, the modeling operations that we're doing are very similar to the ones that we used before when we were making the 2 square panels. Now I'm moving the polygons down to adjust the angle of this area. I want these specific edges to be tight on the normal. So what I'm going to do is select them and give him a chamfer that is really thin. I realized that I wanted to give a similar angle to the bottom part, but now this chamfer is getting in the way. What we need to do is select the vertices that this chamfer created and then collapse them back. We're essentially restoring what was there before. And once we collapse them, we can move them into place, make sure they're straight before we start creating that angle. Once they're in place, we can select the vertices that are on the bottom of this model and push them down, and that's going to create this gradual curve. This curve will definitely show up on the normal map and on the height map. Once we're happy with this operation, we can continue adding the chamfer where it was. Right now the chamfer is not completing because there's a polygon that is missing. So let's grab that edge and extrude it down, and this way we can complete the chamfer. I'm gonna make sure that everything is welded together and move forward with the operation. I'm only selecting these 3 edges because the other ones I do not want them to be rounded off. I'm checking the rest of the model to make sure that everything is consistent. After I'm happy with it, I'm going to commit to the operation. One of the areas that needs more detail is the area that's in the center. Right now, everything is flat. So let's select the edges and the topmost area in that center. And then we can add a chamfer, but remove the segments. It's essentially creating a bevel in that area. And with those edges still selected, let's introduce a chamfer to create more segments. This way, when we bake down our normal, we're not going to have harsh polygonal lines. Now we're getting the model ready for the detail that we're going to be duplicating in the center. Let's start off by introducing a new cylinder and making it thin. Then rotating it so it's vertical on the model. So far, I'm happy with the radius, so I'm just going to scale it up to fill the gap. What determines the distance between each of the parts is going to be the array that I'm going to be performing now. So by holding Shift, I'm dragging it to the right and then picking the number of parts that I want, deleting any extras, and moving the ones that I kept towards the center. Once I'm happy with the location, I'm gonna isolate them and attach them to the same model. This way, it's easier to manage them. You can already see the kind of sheen and reflection that these details are going to add to our normal. Sometimes the simple primitives can go a long way. Now we're moving forward with the scarier parts of this model. That is beveling and chamfering the topmost polygons. With them selected, let's start the beveling process. Remembering the numbers that we had before, 0.5 and negative 0.25. But in this case, we can see that there's some pinching going on. So we're definitely going to be adjusting these to make sure we salute a value that agrees with us. We do not want to make it too hard for ourselves to clean this model, but we cannot avoid all of it. So whatever needs to be cleaned will be cleaned. So let's take these vertices and make sure that the roundness is smoother. Let's remove any of the pinching that will eventually show up in the normal map, because this is a tileable texture. If it shows up in one area, it will repeat on your environment. I'm realizing that these vertices specifically are very tight and they're not gonna allow us to chamfer the top edge. So I'm gonna weld them and then eventually chamfer them again. But for now, we need to put them back the way they were. Let's do the same thing with the top part of the model. Select those vertices, collapse them. And now with them collapsed, we can select those edges that we want to smoothen out. So what I'm doing is selecting the polygons, converting the polygons into edges, and then deselecting the edges that I do not want, similar to how we did it before. And now we have the perimeter selected. We can move forward with that chamfer. We need to make it thin in order to make sure that there's no distortion in any of the areas of the model. so it's important to scan the model in every angle to make sure it works. Now that we finished the operations, we can restore the work that we did before on these two edges, making them very tight and making sure there's no overlapping. We're getting close to the finish line. Now, like we did before, we're gonna add that accent detail. But first, we need to create a boolean that cuts through the center of this rectangle. And for that, we need a cylinder that goes all the way through. I want to center it on the rectangle, so what I'm gonna do is introduce some segments that are centered in both directions, and this allows me to snap this circle where I need to have it. Looking at the top view, which is the most important, I'm determining how big do I want this detail to be. I do not want these details to be too large, because I'm thinking about these being a full wall. These kinds of trims can be big in the environment. I'm happy with this size so far, and now that we are committing to it, I can select the edges and the corner and create a chamfer. And then followed by similar operations that we've been performing on other parts of the model. I do not know why this always starts with an exaggerated value. If somebody knows how to change it, please tell me. But now that I have the value that I want in place, let's commit to it and create a little bit of separation on these vertices. And with this specific area is complete. Now what we can do is bring our accent detail from our previous model, duplicate it, scale it into place. We do not need to model that center detail from scratch. But of course, if you want that specific detail to be unique on your own texture, feel free. And this is gonna be a theme going forward to the new panels, as I'm thinking of taking parts that we already made to create them. Now that we've finished our large detail panel, let's create a large panel that is more simplified. This model is gonna be really straightforward because we're gonna start off with a part that we already made. So let's duplicate one of the areas from the topmost trim and delete the things that we do not need. With the desired components left, I'm gonna grab the vertices that are on the left and move them. This way we extend the width of this part. We're gonna be using a symmetry, so we have this part duplicated on the left. pivot point to the center so I can relocate this part to where it needs to be. This part needs to be on site. It cannot work remotely. According to the size of the panel, we need to scale it down. I'm using the snapping tools in order to get the height of this part where it needs to be. Now let's create the bottom part of the panel that is missing. Oh wow, forgive me. We need to move this up. Let's isolate these two parts so we can work on them by themselves. I'm gonna be taking the edges. Now let's take the edges of our new part and extend them to the sides. This way they match the size of the overall panel. I'm not happy with the way these cylinders end abruptly. So I'm thinking of creating a part that caps everything off like it did on our previous part, but in a different way. So let's move a cylinder up and try to center it within the gap. I'm making it so it's really round, so I added 64 sides. It's not going to be using subdivision, so whatever we see here, it's going to show up on the normal. Now with it matching on the edges, I'm going to select the outside of this cylinder and extrude it up until the point where it starts penetrating the other parts of the model. Once it does, I'm going to delete the left half and also the interior. And I'm going to bridge the top and the bottom. Now I'm selecting the polygons that are on the left side and extruding them so they go all the way towards the center. And this way it's creating a container for the cylinders that we have. Now I'm going to extrude the ones that are on the outside of the cylinder towards the edge of the trim. And once we're happy with this part, we can duplicate it so it's on the left side as well. But before we duplicate it, let's add a little bit of a chamfer to this edge. And just like before, we're going to smoothen out the edges with some segments. I'm applying a different material to this specific part, and then using symmetry while making sure that the mirror plane is on the center of the model. I'm noticing that these edges are not in the correct location, so I'm just gonna adjust them. Now let's work on the bottom part of the panel. I'm moving the edges so they match with the part that we just made. And then let's introduce some cuts. also some vertical cuts to cut the model into thirds. This way we have some edges to work with as we define our details. Let's divide the sides into thirds as well. Now with these new edges, we can move the center part down to create some angles. I'm adding this just to make sure that they're 45 degrees. I rotated a very simple geometry to serve as a ruler. Now what I'm gonna do is grab the bottom part and detach it. And separate them so we can model them individually. The same operation needs to be done on both sides, which is selecting them and bridging the gap. Now let's select the edges and add some chamfers. I'm thinking about what the radiuses will be, so I'm selecting some while ignoring others, and I'll eventually get to them. These are the ones that have broader curves. And these are a bit tighter. And now I'm selecting the ones that are on the edges of the panel. I'm not chamfering the ones that are on the top part because they're attached to other parts of the model that do not need chamfering. Similar to before, we select the polygons and introduce a bevel, remembering the values that we had, 0.5 and negative 0.25. And then we check the edges to make sure that there's no overlapping. Because this model is much more simple, we don't see any overlapping, any issues, so we can select the edges like before and introduce a chamfer to smoothen everything out. Believe it or not, we're getting close to the end of the modeling for this model. We're just going to be introducing a few details that are on top. These vertices are not allowing the chamfer to succeed, so they need to be moved towards the center. Once we have more space in that area, the chamfer is going to be smooth. Us. Now I'm going to be using the grid to resize some of these parts. I like them to be on the grid and makes it easier when we're modeling and unwrapping. our parts use grid measurements. In order to add additional details, I'm going to grab the part that we made previously, the one that has the yellow color, and then I'm going to bring it down and delete the bottom portion. I also removed that yellow material as I wanted to match the panel below. Now with the bottom portion deleted, I'm gonna rotate it and flip the normals. Grabbing the border, I can extrude it out to extend a plane. With the normals flipped, I'm restoring the turbo smooth. I'm scaling this part down and moving it into position. While looking at the top view, I'm playing around with the location of these nostrils. The location of these circles. As you can see from the top view, it looks like the part is modeled into the panel. And eventually when we bake our normals, it's gonna show up that way. We don't actually need to model this part into the panel itself. It's okay if it's a little bit raised from that panel. Now I'm gonna create a pill version of that same model, using the bridge to seal the gap. And using the top view, we can confirm that it looks like something that was machined out of the panel. And with this, we are done. Congratulations, you're more than halfway through the modeling. You've created 3 large panels, but we have 3 smaller panels to go. I hope to see you on the next video so we can continue on the journey of creating an environment like the one that's playing in the background. Thank you.